Okay, so we're moving on to factorising. So we've got two examples here. We've got factorise fully x to the 4 minus y to the 4, and part 2 is 12x squared minus 75y squared. So we'll deal with those first. So just dealing with part 1, x to the 4 minus y to the 4. So we can see here there's two parts and there's a minus in the middle, so it looks like a difference of two squares. So how we factorise a difference of two squares is two open brackets. What multiplied by itself gives me x to the 4. That's x squared. So x squared and x squared. The signs are always plus and a minus with a difference of two squares. And then what multiplied by itself gives me y to the 4. That'll be y squared and y squared. Now what's actually after happening as well here is that we have another difference of two squares. So you can't do anything with the first bracket. It's done as much as we can. But with the second one we can factorise again. And in that way then we just open another difference of two squares. So we've got x and x and y and a plus and a minus. So again, with that one, just be careful. You have to continue on and you always factorise as much, basically in equation, as much as you can, basically. So that's part 1. Part 2, 12x squared minus 75y squared. So it looks like a difference of two squares, but unfortunately it's not, as, 12 isn't a square number, 75 isn't a square number. So we have to kind of rack the brains and see. It does have a number. They do have a number in common though, which is 3. So we'll start by doing that. So 3 bracket, inside we've got 4x squared minus 25y squared. So now we can see a difference of two squares occurring. So we leave the 3 out. Inside then, and again you can use your square brackets if you'd like, we leave the 3 outside, and inside we have got 4x squared minus 25y squared. So 1 multiplied by itself gives me 4x squared. That's 2x and 2x. And then a plus and a minus, always the signs, as it's the difference of two squares. And then we've got a 5y and a 5y there. And that's that factorised fully. To move down to the other one, where it says example 2, simplify x squared minus 9y squared over 3x plus 9y. So with regard to simplification, I suppose none of these are in a way, or written in a way that the fraction can be simplified. So basically we're going to rewrite them using factorisation. So the top line, if you look at it and just look at it on its own, it's a difference of two squares. So I'm going to open that out. Again, what multiplied by itself gives me x squared, x and x. What multiplied by 9y squared gives me, or itself gives me 9y squared. That'll be 3y and 3y. So then plus and a minus. On the bottom, we've got 3x and 9y. So again, it's not a difference of two squares or anything like that. It's just a kind of a basic factorisation in that there's a number common, and the number common is 3. Inside with them we have x plus 3y. So I'm delighted to see that we've got a bracket common above and below the line. So I can cancel them. I'm left with x minus 3y over 3. And some people always wonder, can I cancel that 3 with that 3? No, I can't. All of the bottom line must go into all of the top line, and as it only goes into one of the parts, I have to leave it as it is. So that's it, simplified out fully.